Hi, I'm David with General Air. The Lincoln Squarewave 205 or the Miller Syncrowave 212. Let's put these machines head to head and look at the features, benefits, differences of both machines. Alright, the Syncrowave 212, you can see right now it's showing 212 amps. I do have this machine plugged into 220 volt single phase. Now the process button on here is going to get us into this menu where I have some options. I've got AC DC, high frequency start, means it's going to give a little radio frequency start to break the gap between the tungsten and the work, so I don't have to actually touch the tungsten to the piece to get the arc to start. And then I have AC and DC lift start, and that's where if I don't want to use the high frequency start for whatever reason, I can just touch that tungsten to the workpiece and then the arc just comes off nice and smooth. Here is our DC stick options. I haven't stick welded this machine just yet, but I probably will in the future here. But here is that MIG spool gun that you can connect into this machine. Now that one's unique to this machine. I don't see that in a lot of other brands where you can take a spool gun, plug it into this machine, and run aluminum wire. So say if you had a big aluminum project that you were gonna TIG weld, but you wanted to, tack things or do some easy welds with wire, then you have it all in one machine. Now I'm gonna start off with DC TIG with a high frequency start. So I'm gonna roll into that, select that. You see the little check mark to the left of there. Now on the trigger, it's gonna ask me if I want a foot pedal or a hand amp control. So I can switch these guys up. The machine comes with the foot control, and that's what I'm going to use. Hand amp controls are nice if you need to free your feet up, if you're going to be climbing on a ladder or whatever. Now pulse, I have it off right now. I'm going to turn it on a little bit later. This is how I turn it on, just by that little scroller. So we're going to take a look at that. I just want to weld with it straight at first and see what it can do on a straight arc. And then tungsten size, it's just recommending the tungsten that I'm using for my application, which is a 332, and you could really use any color that you want. I like the blue, which is 2.5% lanthanated. The only one I can't use on an inverter is a green. That's with most inverters, actually probably all the inverters I know of. They don't like that green tungsten. It kind of shakes them apart as you start to weld. So most of them, you won't want an alloyed tungsten. Like I said, I'm going to be using that 2% lanthanated. I got a little home button here. I'm going to click that. There's also an auto set button. I've never been a fan of auto sets on TIG welders. You can click that if you want and go through the whole thing, and it'll guide you step by step into what the right setting on the machine is. Not particularly a feature that I use all that much. So we're just going to do a straight arc, and I'm going to go to 150 amps, and we're going to weld some 1/8 inch mild steel to start off with. Right, just with like any Miller product, the arc start is fantastic, definitely as expected, and the arc is very soft. It's compliant. I like the foot pedal response. Really no surprises here when it comes to just a straight DC arc from Miller. They've been doing this for a long time, and it all looks good to me. The Squarewave 205. Now, when I click my process button on here, I've got AC TIG, DC TIG, DC stick, and I also have some AC stick on here. Didn't see that with the Syncrowave 212. Just had DC stick there. It's interesting to have. Not sure I would use AC stick, but some people like it. I'm going to look at the DC TIG, and I'm just doing a no pulse run here, just like with the Miller, and I've got that low end of 8 and all the way up to 205. I'm gonna put it right at 150 amps, just like I had the Miller, and I don't have my pulse option on or anything like that. Let's see how this thing welds. All right, there's the Lincoln with just straight DC and running on the mild steel. The foot pedal spring is pretty light, so when you rest your foot on it, it starts. And then you start on this Lincoln's pretty harsh. You don't have that good smooth ramp up that you see with the Miller. But once I got into the weld, the arc is very stable, very smooth. When I put a little bit more throttle down to try to start moving faster, that's where I noticed that there was a lot of fluctuation in the amperage just because that light spring in the foot pedal. Something I certainly could get used to, but it's noticeable compared to the Miller's foot pedal. And on the end, the ramp off, or when I taper off on the foot pedal. It just clicks right off. There's not a taper off. So just some things I noticed on the starts and stops on the Lincoln. Now what I want to do on that DC TIG with the high frequency start is I want to turn my pulsar on. Now this machine will go all the way up to 150 pulses per second. And that means the arc is going high, low, high, low, high, low. This really helps when you get into thin material to have that really, really fast pulse, because it essentially breaks that electromagnetic field hold that the arc has on the puddle when you're dealing with really low amperage. So you can turn that really high. Say if you're going to weld some razor blade edges together, that helps that puddle move along. Now, I'm not going to be welding razor blade edges together. I'm going to stick to that 1/8 inch steel, and I'm going to go to my favorite pulse. It's about 0.9 pulses per second. I'm going to try to get that great stacked dimes pattern. Let's check it out. All right, now I've turned my machine to pulse, and I'm at 0.9 pulses per second. After I started welding, I realized it's a little bit slow. Probably would want to move a little bit faster, so I would move up that 0.9 pulses per second to like 1.3 or so. Either way, the transition from the low to the high amp on the pulse is extremely smooth, and it's very predictable. And that's what you want out of a pulse. And all I'm doing here is just moving forward on the leading edge of the puddle, and then waiting for that high amp pulse to go off, and adding filler metal, and then repeat as I go along. Very, very stable pulse for sure. Now I'm going to turn the pulsar on, so I click this big button and it goes right into pulse. So when I click on this, here we go, I can go from off to 0.1 pulses per second all the way up to 20 pulses per second. This is a lot lower than the Syncrowave 212 that could go to 150. So it's not going to be that really, really high frequency pulse that we can weld those razor blade edges and stuff like that. For me though, the main frequency that I use for my pulses, that 0.9. So I'm going to click on that again. So I've got that. I can go to my home button. Let's weld. Now the pulse I thought was actually a little bit better than the Miller's. The pulse was that harsh snappiness of the square wave actually gave me a little bit better pulsing profile. I really like these stacked dimes that I got with this one. Same issue here with the foot pedal, is it just comes on with everything, and then really hard to modulate and get in that sweet spot on the foot pedal. But I did like its pulsing better than the Miller's. All right, now I want to put this machine on some stainless steel. I think that it's going to weld great because it welds DC steel great. Really the biggest thing with stainless steel is you need to keep the material cold, and you do that by going fast. So I'm actually going to turn my amps up on this so I can move quicker, which is ultimately going to give me less heat input. And I have a gas lens on my torch, so that's going to give me plenty of argon. Let's check out how the Syncrowave does on stainless.
I ended up turning the Miller up to 190 amps and the pulses per second to 1.3 pulses per second. That's in order to get a little bit more speed on the stainless steel. The faster you go, the less heat that you put in there. Now, one thing I noticed on the Miller that's a bit different than the Lincoln is that it's going to show average amperage displayed on the screen. So my top end's 190, and you'll see the screen's a lot lower than that. This is going to help you calculate heat input, so you can use that in the calculation to figure out how much heat you're dumping into there. A light gold and white is really what you're goaling for in stainless steel. And it looks like we got plenty of that in the Miller. Very nice job.
I'm going to leave my pulses on for the next weld, which is a stainless steel 304 base material. But I am going to turn up my amperage like I did with the Miller, just so we can go faster. Now the stainless steel, you can see comparatively to the Miller, it has a lot more blues and purples. This suggests that it got quite a bit hotter than when I was running on the Miller. I was running the exact same amps and pulses per second, 1.3 pulses per second, 190 amps. That was about 3/4 of the way on my throttle. But same torch even, I just swapped the torch over, so I'm using the same exact torch on both machines. So that wasn't really a factor, but you can see a lot more colors coming out of this one, which suggests that it did get a little bit hotter. And that I would say that's with the Lincoln, that high amp pop on the pulse just feels a lot stronger than the Miller's. Probably why I like the crispness of it, but it does give you a little bit more heat input. I'm going to jump back into my process menu, and then I'm going to switch my machine over to the AC TIG side. Once I do that, I can answer all those same questions, the trigger and all that stuff. But what unlocks here is the AC wave shape. Now, this is what I want to see on an AC machine: an AC frequency control and an AC balance control. So what the frequency control does, and you can see with this little cool graphic, is as I turn that frequency down, you can see that the arc got wider. You can also see that the tungsten balls up, and that is true. It's harder on the tungsten, so the tungsten wants to melt. And the puddle gets wider as well. The higher the frequency I go, the tighter that puddle gets and the sharper my tungsten stays. So when I'm welding thin aluminum, a higher frequency, that is the key in a successful hot thin aluminum weld. So the adjustment here is from 60 Hertz to 150. So I'm gonna weld some 1/8 inch 6061. I'm gonna start with a 85 Hertz here. So I'll click on that. Now I'm going to go back. I've saved that 85 Hertz. Now I'm going to go back to my AC balance control. What AC balance control does is it tells how much time the arc spins in negative and positive. The lower that number, this is always talking about the percentage of negative in the sine wave. The lower that number, the more cleaning action I'm going to get. You can see the little frost lines that are happening on that. As I turn that up, I don't get as much etching, so I don't get as much cleaning action. I like to be on the highest percentage that I can, so I'm going to leave this at 80. I've got some relatively clean aluminum here, but if I got on some more oxidized aluminum or some cast aluminum, I would be turning that down. But let's see what it looks like at 80. So I've got that clicked and saved. I'm going to hit my home button, and as far as the amperage goes, go to 190. We'll see what that does. This is a 6061 base material, and I'm using a 5356 filler metal. I like 5356, it's nice and sticky. I've got 190 amps on my machine, 80% negative, 20% positive, and then I'm running an 85 frequency, 85 Hertz. So this is a much lower frequency than I typically run these fillet welds, but I like how stable this arc is. It came on nice. Sometimes alternating current machines or any machine on AC will hunt a little bit in the start. This one just struck and it was off to the races. Very good cleaning action. I don't see a lot of black specks floating around in the weld, and that's the magnesium and the aluminum oxide. So it's pushing those out of the way. I like that I can run a higher negative balance on this machine and still get a nice clean weld out of it. Some machines, when you go that high with the negative, you get a lot of black flecks and a lot of just trash floating around in the weld. But this one did a great job of cleaning that out. Got a nice wide buttery puddle. And there it is. Jumping into the AC side of things, here's the AC TIG. I'm going to click that. Got my amp range, but I have some other options. Now I usually don't use pulse when I'm on AC, but here's that AC balance control. One thing I noticed about it, there is an auto set on there, which is interesting. It probably leaves it at 75-25, or it could be a progressive auto set. I've seen that before, where it starts at a lower AC balance and moves to a higher as you start to weld. But we can play with that a little later on. Now I'm going to turn my electrode negative. This one goes all the way up to 90-10, which is what I really like. If I've got some really nice clean aluminum and I don't need a lot of cleaning action, I got 90% penetration, 10% cleaning here. Now, one of the big differences you see is this doesn't have a graphic like the Miller does. If you forget what this setting does, you have to go and look it up. but the Miller's nice because it's got that right on the screen. But I like the fact that it'll go to 9010. So I'm going to click that. Then I'm going to go to my AC frequency. Now this does have 10 more hertz on the AC frequency side than the Miller. And remember what that AC frequency does is it changes the cone shape of the arc and allows you to weld that thinner material. So I'm going to go down to about 85 hertz. It's a good place to start. And then I do have a post flow setting for my gas. I'm just going to leave that one on automatic. Let's take a look. All right, our first AC weld with the Syncrowave 205. And this was done with a 9010 AC balance control, and this was with an 85 hertz frequency. And the arc was great. It had a great start, and I noticed off the bat that the arc was pretty small. For the same frequency that I ran the Miller, this felt like I was already in a really high AC frequency. It felt like I was at 120, 130. So it gave me this really tight stack of aluminum on here, and I noticed a lot of magnesium and aluminum oxide floating around. It didn't get much cleaning action at all. I was actually really surprised at this lower frequency, the result that I got, because this felt more like what 150 hertz felt like on the Miller. So I was real curious after I did this one what that the high frequency weld's going to be like. This one turned out great. Let's take a look at the high frequency one. Now what I want to try is to mess around more with my AC frequency and balance control. So I hit that AC wave shape button, and then the AC frequency, I'm going to bring that one up to 150, the highest it'll go. And I'm going to leave the balance, I'm going to leave it at that 80-20. Let's see what this looks like. Going right back into it, same thing that I did last time, same base material, filler metal. The only thing I did this time was cranked the frequency up as high as it'll go. So this is at 150 hertz, and it really gave me a lot more focus of the arc. Now measuring these two out, this one has about an 1/8 inch less leg, so a 1/16 less on either side. So I had a smaller weld and just lower heat input altogether. I like that. I don't like to overweld the material because that can just cause warpage and other heat-related problems. But again, this one lit up really nice, just like the other one did. I didn't have a lot of AC wander, and the puddle is just doing exactly what I need to. This one has a lot more black flecks that are floating around in the puddle, and that's to be expected on these higher frequencies. You just don't have the same time that you would on the lower frequencies to clean the puddle out. So I'd probably turn my balance control down a little bit if I was going to do it again. But overall, it's a great looking weld. Now let's jump into that higher frequency. So on our AC TIG side, I'm going to go to the AC frequency and I'm going to turn that all the way up to 160. I'll leave my balance the same, that 90-10. Let's see what this does. As I expected with that 160 hertz, I left that 90-10 balance control alone. I definitely needed more balance time. I needed more positive because this one did not clean at all. It looks more like welding with aluminum with DC. You can see all of the magnesium soot hung out on the surface, and there just wasn't enough time to get that cleaned out. I'm really surprised at how tight of an arc that this AC, the Syncrowave 205 on AC produces. It was very, very, very small arc. Definitely could have welded some very thin aluminum with it. Impressive. Definitely the wrong settings though for this 1/8 inch 6061 extrusion. I would want the lower frequency back or just more balance control, but you can see the result here. All right, that was a lot of fun. The Syncrowave, for sure, I like the pulse on it. It's very snappy, gives me some really nice stack times. Big surprise on the AC side of things, when you're at a certain frequency, it feels like you're at a higher frequency. It does have a 90-10 balance control, which is what it was at. I could have turned that down to get a better cleaning action, and we wouldn't have had such a messy last weld there, but I really wanted to see what it was like at its highest balance and its highest frequency, and we found that out. One thing I didn't like about the Syncrowave was the weak spring in the pedal. The pedal needed a lot stronger spring. You'd just breathe on it and it would start that arc. So that's one thing that was hard to modulate, just because the weight of your shoe would make the foot pedal go up or down, which gave me some inconsistencies in especially the DC weld without pulse. Now on the Miller side, the aluminum stuff is great. I really like the way Miller welds aluminum. They've had a great recipe for that, and this machine's no different. A very soft start, great low end on this machine. I like the option to throw a water cooler on this, so if you wanted to weld all day long and you wanted your torch to cool down, put a 20 series torch on here and you can weld to your heart's content. And I like the ability to throw a spool gun, so if you have some of those larger fabrication projects that require a lot of tack welds, you're not having to TIG tack everything. It just makes those projects go a lot faster. Hey, thank you so much for watching. Really appreciate it. If you like what we do, like and subscribe, and check out the link in the description below for our website. You can find out everything you need to know about General Air and the stores we have in the Front Range of Colorado.